Hi, my name is Ben Torium, and I'm going to be giving an introduction to MPPTs for Power Electronics course at UBC. I'm going to be talking about the IV characteristics of a solar panel, what is a maximum power point, the working principle of an MPPT, as well as some algorithms. So, we're going to start with IV characteristic of a solar panel. This arises from, as seen in the top right, a current source and a diode in parallel. This is the electrical model of a solar panel. When all of the current flows through the diode, we operate what's called the VOC. The diode will have the forward voltage drop and will be operating with open circuits, so no load. And of course, no power is transferred to the load. As you decrease the impedance of the load, so going from an infinite impedance and bringing that down, you can see that most of the current will still flow through the diode, but a little bit of the current will flow through the load, thus leading to some power transfer. At a certain point, you're going to have more of the current flowing through the load, and at this point, we call it the ISC, the short circuit current. And this means that most of your current is flowing through the load, and very, very little is flowing through the diode. Again, you have zero power transfer at this point. Somewhere in between here, you have what's called the maximum power point. And this might not be as simple as what's seen on the diagram. So we have things like shunt losses, series losses, mismatched losses if you have multiple cells in series or in parallel, as well as shading losses. And what can happen is these losses can cause you to have a bumpy curve as opposed to a nice smooth curve as shown in the red. So we're trying to find the maximum power point. This is the point at which the solar array is operating at the highest possible power. And the reason we want this is because we want to transfer that power to some load. And this is shown very nicely with a PV curve, which is the power versus the voltage, because usually we're looking at the voltage of the cell and looking at changing that. How do we change that though? We want to operate at some maximum power points, but how do we change the voltage that we're operating at? Well, we can change what's seen from the source looking into the load by using a DC to DC converter. For example, if we know that the load voltage needs to be higher than the PV source voltage, we can use a DC to DC boost converter that boosts up the voltage to the load. Now, assuming that the load doesn't really care exactly what voltage you're operating at, you can use that boost converter, and the equation for that is going to be the V out equals D times V in, where D is your duty cycle that is controlling the DC to DC converter. So by changing this duty cycle, we're able to change the ratio of your voltage in to your voltage out. And by increasing it, you effectively increase the voltage of the load and decrease the voltage of your input. Now you can see how you might be able to change the voltage operating at your PV source. The MPPT controller, the maximum power point controller tracker, is going to look at the current and the voltage at the array. It's going to adjust the duty cycle and use that information to find the maximum power point. But it's not as simple sometimes as it may seem. So in this example, we're looking at, say, point A. Well, you can just step to the right, but we're not able to see this curve. So what it does is it's going to change the duty cycle and thus change the voltage seen at the arrays, and it's going to choose some arbitrary direction. If it decreases, it's going to see a decrease in power. Then it knows it has to go in the other direction. It'll increase. As it increases, it'll suddenly see a point where it starts decreasing. At this point, it knows it's gone past the maximum power point, and it'll go back. What can arise is something called oscillating around the maximum power point. This is where you step forward too far, you come back, again too far, and you keep going because you have a fixed power point, because you have a fixed step size. The other thing that can arise is that you get stuck in a local maximum instead of a global maximum. So an MPPT has a bunch of different algorithms that people have researched. Perturb and observe is the one that we talked about here. And this one is most commonly used and is very easy to implement, but there are better algorithms out there. Thank you for listening to my introduction on MPPTs.